Today we are going to talk about probably right along with actually, designing a database or a data schema. The other really important thing, which is querying to get data. And SQL has some really powerful tools for us to do that. And this is actually, especially as a junior dev, where you might spend a bit more of your time is writing queries. Both these skills are important on a software engineering team. Generally, it might be the more senior people designing the database. A lot of the time, the database will already exist. And as you get assigned particular tasks, maybe you have to add a new column to a table or create a new table. And on a team, at least, often to begin with, you'll kind of do that with consultation and mentorship from a more senior engineer on the team. Writing the queries might be something that you do more independently. And someone had a great question yesterday, actually, about, well, we're starting to think about like costs and sales with 32 flavors. What if I start wanting to care about profit and revenue and stuff? Like, where do I store that data? And the answer is, with sort of designing a database, we really want to put the raw data in there. And it's really the queries that let us manipulate and work with it. So it wouldn't be uncommon to, say, have a database that simply stores like sales data, and then a software developer or a business analyst or a programmer analyst or a data science person write some SQL queries that are maybe generating results of like, what's the monthly revenue, what's the monthly profit for the company, and so on. So that's the plan for the first part of our lecture, is talk about queries. For the second part, we're going to look at importing and exporting CSV and JSON files, with a focus on CSV, because that's extremely common. Excel spreadsheets being like the classic use case here of getting stuff in or out of a spreadsheet from a database or to a database, and that's usually done with CSV files. So let's dive on in. And I borrowed a lot of this pretty excellent stuff from the part-time, rather the evening and weekend program, including this CARS database. And so, by the way, some of the assignments this week, you will see, how to install without Docker, how to install with Docker. We will talk about what Docker is later on in this course. In the evening and weekend program, they run to it a little earlier, so I just kind of added these two paths. We are not using Docker right now, so these are our install steps, and it's relatively straightforward. And I'm going to go ahead and do this right now. And I'm also just going to give you all a quick preview of what this data looks like, because this is what we are going to be querying against. So this is a CARS database, and we've got a bunch of tables here. We've got an app user table. We've got a user profile table, a model of a car. We've got a car itself. We've got an advertisement for a car. So this is like Craigslist for cars, right? I can sign on and I can post an ad to sell my car. And then we have a whole bunch of fake data. And actually, let me go ahead and clone this and create this database. And I also am going to see if I can't just import this file into the Draw SQL program, and we can get a nice visualization. So let me open up a new terminal here real quick and do this. I have my sort of system of where everything lives, and this one lives in Code Platoon assignments. Let's see if I have it already. And lo and behold, I do. Perfect. So let's see actually if we can import this into Draw SQL, because Draw SQL and these other SQL programs actually do let you upload a whole SQL file, and we'll see if it handles this schema nicely. And let's see if it complains with having the fake data in there or not. That's kind of the one thing that I'm curious about. And if this doesn't work, I may just move on because I don't want to get lost in this too much, but it would be cool for us to see. Awesome. We got some warnings, which we can probably ignore. And we have a cards database, which is great. You can export SQL as well, and I really don't recommend doing that. You will just be cheating yourself out of learning. So this is great because we can kind of see what's going on here. And let's rearrange this a little bit to maybe make this the order of these tables a little more logical. Let's maybe just do user profile. Let's do it like this. So I think seeing this visual representation of our data schema will help us understand the queries that we're writing. So I sign up for this website and I get an account. And this app user table really represents that core account information for online accounts. And this is a pretty common pattern you'll see where you store, this actually comes from Django when we see Django, where like your user profile information, things like address get stored separately from the account. Maybe when a user like decides they want to delete their account, we actually want to keep the record that the user used to have an account. And so that can be one good reason to do this. And let me go ahead and make this little foreign key connection here. And that's a one-to-one relationship. And so I log into this, Craigslist sell my car online or Edmunds sell my car. And once I have an account, I create a profile, which includes my address information. And then I make an ad. Aaron, as to your point, actually, we can see that our other instructor, Chad, he likes the idea of primary keys having more meaningful names. And the internet does have some back and forth on this. So I'll kind of follow up on if there is like the one right way or not. It may be one of those classic programmer arguments. So once I make an account, I post an ad. And note that the advertisement has a foreign key linking to our user's account ID. So this is really the hub for everything. So let's actually put the user profile down there. And then, as a user, what I also have to do, and what I probably need to do even before making the ad, is I need to upload information about the specific car I want to sell. So for example, I have a 2007 Ford Jetta. That's like one individual car, right? And that's what this car table holds. And so, or maybe depending on the user interface, that happens when I make the advertisement, because if I look here, I do see that the advertisement gets linked to the car ID right there. And again, that's a one-to-one, as this is like a specific car. So I can't have two ads to sell the same car. And note that this gets linked to the advertisement, which is then linked to the user account. And then finally, the database has sort of a general list of car makes and models. So, when you're filling out an advertisement or something online and there's a drop-down list that has all the options already ready for you, this is where that data comes from this car model table. So, if the car doesn't exist in the car model database, I actually can't sell it. So we have to have a pretty good list of car models. And so over here, this car model ID is in fact a foreign key connecting here. And this is actually a many-to-one relationship, or I'm sorry, no, that's correct, many-to-one, as each specific car only has one model. but there will be many models of the same car being sold. So this is our data model. And I just want to check in and actually let me take a screenshot of this and someone please remind me and I will throw that in our notes from today. I just want to check in and see what questions people have about this before we start digging in to querying this database and looking at the data. And it'll help too to see the actual data in action. But what questions do people have or things that we'd like to dig into a bit more?
So is advertisement off of app user for the same reason, whereas like if someone deletes the account, we'd want to still have like a way to see like this person bought from this account that no longer exists, but we still have like an email, like if they're a scammer or something? Or is that
That's
just not?
Yeah, that's a good question. Um, that might be one consideration. Generally speaking, the other advantage of sort of this app user table is you know, if I'm a user, I absolutely have to have an account, and email here is actually unique. Like if we look at the data schema, because you have to have unique email addresses, otherwise you end up in serious trouble. Even though email is not the primary key. And so, maybe as a new user, I haven't updated my profile with my address information. Maybe it's not needed. Maybe the user profile stuff is optional. There are a lot of possible scenarios, but since we know that every user is always going to have an account, that's kind of like the safest and strongest thing to link an advertisement to, if that makes sense.
Yeah, that makes sense. Thank you.
Totally. Great question. Clarice, yes, what's up?
I guess I'm wondering why split up the app user stuff with the user profile stuff.
Yeah, that's a good question. It's a little bit to taste. When we use Django, we'll see that Django does some stuff. The name app user actually comes from Django. There's certain things around how Django handles authentication, where it basically will always create an app user table, and that's how Django wants to do it. It can be, it's a little bit of sort of like personal preference and taste, but because it with Django specifically, because it creates this app user table all the time, in some ways it's nice to not like throw too much on here and put other stuff in a user profile. The example I mentioned earlier of, let's say a user like deletes their account or deletes their profile, but we still maybe want a history of users, or if like we have to ban a user, for example. Like if I have to ban a user, it's useful to have that record. And so app user can kind of do that even if user profile is deleted. It's a little difficult for me to come up with more examples off the top of my head. But as our data gets bigger, as like the user profile grows, sometimes it's nice to just have a really, excuse me, small app user table. Another good example is we might not need this user profile information all the time. So if we're cars.com and we have like tens of millions of, users, we do a bunch of SQL queries where we want like advertisements in the car, but we don't need all this stuff. So sometimes it's easier to have separate tables because I just maybe need a user account ID and email. So you can do that with a query too. So it's a little bit of taste, to be honest, and this isn't a strong separation. But the short answer is, as the data model gets bigger, it becomes more useful to have user profile as its own separate table. For prototyping and beginning, though, to be honest, if you just kind of want to have this all in one, that makes a lot of sense.
Would the app user to advertisement be a one-to-many relationship? Like if you sold more than one car at a time?
would, and by the way, I wasn't muted just now, was I, when I was answering your question, Clarice? Okay, good. I hit mute really quick and confused myself. Sorry, Megan, you were saying, would app user to advertisement be a one-to-many relationship?
Yes.
You are correct. I got that one wrong. That you're absolutely right. Actually, let me.
And as far as relationships, I think the car to advertisement, shouldn't that be a many to many relationship?
So app user to advertisement, as a user, I can post advertisements for multiple cars. So that is one to many. Because I forgot, I didn't think about that. Hey, we want people to be able to post multiple advertisements. For advertisements and cars, let's see, each advertisement should be for a specific car, and each car should not have more than one advertisement for it. So I think no, because this represents like a specific physical car. You know what I mean? Like my car or my cousin's car. And so like if I'm selling my car online on cars.com, I shouldn't be able to create multiple ads for the same car. Or vice versa. Let's see. One advertisement should not be for more than one car. So the reason this is one-to-one is like if you think about kind of like when you write a select query with a join, like there's always going to be one row in our car table and then exactly one row in the advertisements table for that car. But with car model, for example, you know, we could have 500 Fords being sold. So in this car table, there might be my Ford Taurus and your Ford Taurus, Andrew, and Clarice's Ford Explorer. So we have 3 Fords in this car table, but then in car model, or let's just do Ford Taurus for all of us, actually, because there's make and model. And so in car model, there's only going to be one row for Ford Taurus, but it's going to connect to multiple things because we've got 3 Tauruses for sale at the same time. Does that help illustrate things a bit?
I still don't. I'm still not getting it. Because
sorry.
the car model, the relationship between the car model and the car is one to many. So you're having many cars, right?
Correct.
Okay, and then each car gets an doesn't each car get an advertisement?
Correct.
Okay, so it just seems to me that if you would have many cars and many advertisements, so it'd be a many to many.
I think. Oh, I see. I think actually the easiest way to illustrate this one will be with querying data. Because I think that's going to be a much better, like we can actually look at some columns and rows. Let me set up the database and then I will circle back to your question, Andrew.
Got it. Thank you.
Yeah, absolutely. And yeah, let me actually do that because I do want to make sure that we get to the database and the querying. And so let me go ahead and set up this cars database. And I believe I've actually done this already. And is the font size okay here for everyone for P-SQL? Okay, does anyone want me to bump it up a notch? It can't hurt. So if I list my databases, I think cars is in there. I'm actually gonna drop I actually am not going to drop the cars database because while I'm 99.9% certain rerunning the query will build it up just fine. I don't want to actually forget something and get myself into trouble. But just sort of quickly switching gears here, just to demo building the cars database. I've cloned the cars database. I'm in the same directory as it. I'm going to run pSQL. And then I simply, I believe, use /i to run init SQL, which will create all of the tables and feed in the sample data and script SQL. I actually have to check what I wrote down if we need that or not. That one might be something else. Let's see what's in here. Oh, script SQL is empty. So we just have to run this init SQL file that has everything. And let's see if the rest of the world agrees with me here with car to car model. Yeah, so I think they have a one-to-many here. Yeah, so I think querying is going to be the best way to dig into this more. Let me go ahead and pop over to VS Code so we can do some querying. And I've got this queries SQL file in the same directory that I ran this. So like I should be able to do select star from cars, and let's just make sure that this works. And indeed, I'm actually in the wrong terminal. Select star from cars, relation cars, probably because car should be singular, if I had to guess. And the way I can confirm is let's do /d, and indeed the car table is singular here. So let's try this again. Okay, awesome. So that's a good sanity check. And actually, this is a great time to kind of circle back to your question, Andrew, now that we have this up and running. Let me do select star from car, join car model, I believe is the table name. Actually, let me look at the car table. So car has car ID. I'm actually going to build the query up here. And this is helpful because I can write my SQL here and use pSQL to like explore my data shape. I could also, honestly, having the SQL file open here is not the worst idea either. And actually, let me do that real quick because I think that'll be really helpful for us. So let's go here. Let's go here. Let's go to our cars database and let's just open up this init SQL file. And now this is really nice because I can have this as a reference as I code. And the more that our programs get bigger, I think the more and more you start using split screens and stuff so you can see and reference other parts of the code, the easier it makes life. So let's see if we can run this and if it works. So this does work. Let me start getting rid of information we don't care about in this query. And though I'm going a little off script here, this is actually a really good example of query design to solve a real problem. We want to look at the car and the car model information together. Let's start by getting our joins right. I might even add in the advertisements in a bit. And now that we have the joins, let's start looking at the things that we care about. We care about car ID. Let's look just at registration number. Like a couple things just to help make things clear. Car model ID, and make and model. Let's try those things. And I'm gonna put this over here. And let's see, I would hope that in this, there's like duplicates. I don't know if anyone has, so there's multiple Kias. We might actually need to inject some data here to look at this properly, but let's go ahead and run our query. And it looks like I need to. So here's another good lesson, which is that when you start doing joins, you often will need to put the table name if like the column is shared across tables. And I might, if I can't get this one working, I might move on just in the interest of time. Oh, I see. Registration number is from the car table, I would imagine. There we go. So I really, I should insert some data here where like someone else is buying an Audi A1. But Andrew, to circle back to your question, let's just pretend for a second here that this is an Audi A1 as well, right here, and that the car model ID is also one. We haven't connected this to advertisements, but you could imagine that as a next step, where let's say you and I both own Audi A1s, and we both are selling our cars. So in this case, in the car model table, there's only going to be one row for the Audi A1, but it's going to be referenced multiple times from the car table because both of us are selling the same kind of car. And so like you have your, 2012 Audi A1 for sale, and I have my 2014 Audi A1. So we've got like different registration numbers and stuff, but the same model. So hopefully that helps illustrate a little bit more why we have a one-to-many relationship between car, or many to one between car and car model. Like there's going to be multiple models of the same car for sale. And it looks here like they have one-to-many between advertisement. So maybe I missed something there, but I think I'm not sure about this because I still feel like you shouldn't be able to have two ads for the same car, but maybe that's not correct. Maybe we want to be able to do that over time. So let me pause here actually and see if folks have questions, and then I do want to keep rolling with SQL queries. But if folks have questions about anything that I've been going into, now's a good time. Okay, cool. And let me pull up my notes. So we've seen select statements. And I think I'm going to spend a little time down here for now. And then I'll move some queries into the SQL file as I go. And the basic of a select statement is select star for everything from some table. Select star from app user. We don't always want all the information. For example, maybe I only want select first name, last name, email from app user. So this is already how we can start to focus our queries. We can grab just the columns that we want. We can also limit the number of queries that we make. Like, let's say maybe for advertisements, for looking through advertisements. Select star from advertisement so we can see all the ads. But let's say we only want to see the first 10 ads. Right. And so when you're working with the Rick and Morty database and it's giving you pages, that SQL query being run by, you know, maybe the Flask program or the Django code for whomever wrote the Rick and Morty API is running some SQL queries probably with a limit. Because if you're Netflix or Google and you have a huge amount of users, it can take more time and effort, and we don't want to get everything all at once all the time. So the limit is actually really, really useful. And in fact, let's go ahead and let's just get the first 5 users. Right. So that limit sort of argument that we can put at the end of a select statement is super helpful. You all have seen like the where statement. It does an awful lot more than just like simple equality comparisons. And to illustrate that, let me actually pop over to the lesson here and roll down to this table. So this where statement can do an awful lot. And you can see this sort of general syntax of it here, right? We're going to select from a table and where filters our results, right? You could imagine SQL where clause Venn diagram. So we should probably add this. Yeah, I don't know if there's I'll try and find a good one later, but you could think about where is sort of a subset, like we get all the users, but then we filter it. So you can do an equality operator both for integers and strings. You can do not equals with these kind of back-to-back angle sort of angly things. Greater than and less than, I think we're used to. You can do less than characters, right? Which will just sort of go in alphanumeric order, which under the hood is doing Unicode or something. Greater than or equal to, less than or equal to, something extremely useful, between. And in fact, let's see if we can't use between, maybe for some dates of advertisements. So let me go ahead and select star from advertisements. And we've got an advertisement on January 3rd of 2014. And then some that go on to later times. So let's see if we can maybe get all the advertisements in the month of January. And I'm not 100% if Postgres will handle these strings well. So this is a little bit of an experiment, but I think this might work. we might need to use a date range function here. And if so, I'll circle back to that later, as that stuff is a bit more complex. But nope, lo and behold, Postgres is really smart. Postgres can take dates and date times and all sorts of string formats. It converts them into its own sort of internal date object. And under the hood, advertisement date, Postgres stores it as a date object. It just formats it as a string for us to see here. And if we looked at the advertisement date type, in fact, we can look at it right over here, where I have the schema pulled up. We can see the type is timestamp with time zone. So there's a particular data type that Postgres is using there, but it's storing that timestamp at essentially as like its own little timestamp or date object, and it'll convert it back to whatever format we need. But so this has a timestamp with a time zone, and that's how all this stuff starts. So this is great because now I can get all of my queries in January, right? And so let's actually put this up here, because that one I think is pretty useful. So between is really useful. Like is also really useful. And so for these 32 flavors exercises, you know, if we had messy data where we don't have everything really well organized, and we maybe had a bunch of flavors crammed into, you know, the description field of a sale column or something, we could use like. And for like, we can do all sorts of pattern matching. The most important thing to know is that this % represents a wildcard, meaning anything. So this will match anything that starts with span. And so you can do all sorts of different interesting things with this. And in fact, let me take a quick look at our maybe car models. So let's say we want to find all the models that start with A. For some reason, like let's pretend that maybe we didn't have car make information, and so we had to query this a bit more robustly. And let me go back up here so I can use this as a reference, where model like and so you can see we're getting everything here where the model starts with A. I could put a % before this too, so there's a lot of things. Like for example, what if someone screws up and some makes are Mercedes-Benz and others are just Mercedes? Data is messy like that all the time. Well, let me go ahead and put this in our notes as well. And that should be with an S, because I'm going to run this with a Z and it's going to fail. And this is where SQL can be a little tricky, because there's really no good error message that's going to tell me I have a typo here. So sometimes you just have to double check, or honestly, that's the value of retyping code sometimes. But so, you know, if someone had screwed up and we had some Mercedes where the model was, or the make was Mercedes and the other was Mercedes-Benz, this would find both. So like is extremely powerful. And just to show the flip side of like, you know, we can put the % there, we can have % on both sides of it, and so on. And I just want to pause and check in and see if folks have and any questions about this like or between or sort of these tools with querying thus far. And I can't always see the hands up. So if someone has their hand raised, please feel free to just speak out.
Is like used mainly for strings, but or if you had like a number, could you say like let's say you want to check like the first couple like digits of a number, could you do something similar?
It would depend on if Postgres was treating that as a number or a string. Like you can store a number in a varchar and then Postgres treats it like a string. With numbers, if it's an actual integer or number field, you're probably a bit better off with greater than or less than. But I'm actually not certain if you can use it. I would have to look that up. There is probably a way. The key piece there is you might need to sort of like convert an integer essentially to a string value, and then you could use like if you wanted to find 5, 15, 25, 50, 75, 524, like all numbers that have the digit 5 somewhere in them, that would be one way to do it. But remember, you've got greater than and less than and all these other comparison operators as well.
All right, gotcha. Thanks.
Yeah, that's a good question. And there probably is a way to do that. Postgres and SQL, but especially Postgres gets extremely powerful. And the last piece here is this in operator, which is super useful because we can give it a list of stuff. So just to go back to our code, let's get, so the other way to deal with this would be, we actually, I should insert this sort of dirty data because this is a really good real world example. I'll throw this one in the SQL list as well. That actually would be the better way to handle if we had multiple classes. And another example would be, let's say we want to find all the Mercedes and all the Fords. So something did not go right there, and I think I'm misunderstanding.
I think you need to add a wildcard to Mercedes because the actual model is Mercedes-Benz, right?
Oh man, that is an excellent point. You are absolutely right. And that just goes to show how tricky this is. I don't think this will work, but I'm going to try. I think this is going to fail because Postgres has a bunch of useful functions. But let's see. Or I might be able to, I don't know if just the wildcard will work. No. So we will do it the simpler way for purposes of illustration. There is absolutely some way in Postgres to kind of combine the like wildcard within. You can nest queries and do all these crazy things, but it gets complicated relatively quickly. So here we can see all of the Mercedes models and all of the Ford models. You can also use the and or operators. So let's see, for this example, it's a little more contrived. I can't think of something off the top of my head, but we could say maybe, and car model ID is less than 53. I don't know why we would want that specific query, but just to give an example of how you can use and or in conjunction with these other parts of our where clause. And so there's some other examples here, like kind of going through the tutorial, just to illustrate some of these again. We can look at our users. And all the emails really should look like this and end with .com. Right, but that would give us all of our emails. So there's a lot of really cool things we can do with this. And I just want to pause and check in and see if folks have any questions or anything that you'd like me to touch on or go over a bit more again. Okay, cool. Postgres has some really powerful features called aggregate functions. And this is useful when we want to start like getting data about our data. For example, there's something called count. And actually, let me go up to app users. So here we're getting all our users. Let's say I want the number of users. If I use this count function, we are telling Postgres, count the number of rows that this query gives us back. And let's say, I was just doing it like this. I could use count here in the same exact way. And it's the same thing. Right, so it doesn't really matter for if we're just counting a row, what we would want. You can also, I believe, do aliases. So with as, I can create an alias really for any column row, or in this case, you'll note that Postgres actually sort of aliases this to count by default. So if I want this result row to have a name a bit more meaningful, I can do it like this. I can use this as alias. There's also an average function, AVG. And actually, if we let's look at the car table really quick. So a car has a number of owners. How many people have previously owned it for each specific car that we're selling? Right, so all these different cars been owned by one person or three person. Let's say we want to find what's the average number of owners for all the cars that we're selling. On average, each car has been owned by almost two people. What if we want to find the average number of owners for all the Fords? Let me make sure I have that. I do have that primary key, right? And car model ID, where car model make equals Ford. On average, and I'm going to do a sanity check here, and let's return the make as well. Oh, because it's in group by, it won't let me do that. Let's change Ford to Mercedes Benz and see if something changes. What about yes, please. There we go. So now with a different model, I'm getting a different number, and that tells me that my query is probably correct. We could, especially since this is made up data, we might not always see a lot of variation. But I believe that query is correct. So that you can start combining these things in really useful ways. Or for example, let's find the average number of owners for cars that are made before 2008. And by the way, speaking of strings and integers, note that, let's see here. Oh no, manufacture year is stored as a string. So I think this is just more the syntax of our SQL query. Though I suspect this would work without the quotes. Yeah. So, right, cars have slightly less owners on average from before 2008. So you could see how if you're running a business, having some person whose job it is to write queries for all sorts of stuff like this is really useful. So I just let me stop sharing my screen for a moment. Well, actually, before I stop screen sharing, I just want to check in and see what questions people have or what's on people's minds.
Adam, can you just walk through the join function logic again?
Oh, through joins? Yes, we are actually going to dive into joins a little bit later in the lecture. But let me talk on that briefly now for one of the queries that we ran, and then we will take a break, and then we will dig into more stuff. And just to give you all a heads up, I apologize if we aren't able to get to group work today. I dug in, I think, a little bit in like looking through the schema of the cars database, but pretty much everything we have lined up for today is pretty useful. So I want to make sure that we cover it. So it might be a shorter morning work session, or it might end up being in the afternoon, but either way, we'll make sure to take like a good amount of breaks. Let me quickly talk about joins, and then we will take a break. So let's go back to one of my queries. Let's get rid of this average stuff so we can look at the join just a little more clearly. And I will talk about what's going on. And let me go ahead and put this into code here and break it down, because I think that's actually an easier way to talk about it. And remember that SQL doesn't really care about the about line breaks. So breaking down a select statement. Select, we tell SQL that we're querying. And one moment. Excuse me. We tell SQL the columns that we want to get from all the tables that we query, right? So here I could put, make, model, number of owners, or number of doors, or whatever it is. But we're just doing star for purpose of explanation. From tells the query, where is this data from? We're going to get it from the car table. This is more advanced and we won't see this, but you can actually nest results and like do stuff like this. Like I could construct another query and use that result set, right? And imagine here like an array of objects, or an array of arrays really is the better metaphor. Like think spreadsheet, a result set is a whole bunch of rows. So we are getting this data from the car table. And if I am not doing a join, that would be it by itself. maybe I want to filter my result set. Like that. What a join lets me do is connect tables together. And if you all look down here where you see this results, you can imagine if you were working with spreadsheets, literally taking the car model spreadsheet and copying and pasting all of those columns as columns like in the cars spreadsheet, or you make a new spreadsheet and you just paste it all in when you have all the columns for both. And then we need to make sure that the rows are properly lined up. That for this particular car, that has this car model ID of 13, it's connected with the right data here. Now, why car model ID here says 116 and here it says 13? That is a bit of a mystery to me. I'm not gonna lie. I actually inserted the Hyundai information. Let's look at the Fords real quick. Oh, I know why. I'm losing my mind. It's because of the naming is why. Car model ID matches. Yeah. Okay. So this is in the great debate between what things should be named. This is an argument for not naming things because I already like just naming primary keys ID because I already just got myself confused. To go back to this example, car model ID 116 116. Car model ID is our foreign key. So like I'm already getting a little confused just looking at this. And I think car model ID has like two. Yeah, there's something in here I can clean up because I think like this car model ID of 13 is I'm getting down in the weeds here a little bit, so I'm not going to get lost in here. But point being, I find this naming scheme a little confusing. I like primary keys to just be named ID. And in fact, we could do let's car yeah, I'm not going to kind of go down that road right now, though I can if it'll be helpful. But to go back to this to answer your question about the join. So we've got this select from, we've got this where, which can filter. I want to connect my two tables together. I don't want just this car table. I want to join on another table on car model. So we're combining these two tables together. When I paste all the stuff from one spreadsheet to another and put them together, I need to tell SQL and Postgres what the connection point is. And the connection point is car model ID, the foreign key of the car table, needs to match up with car model. And this is what drives me nuts. I think this should just be ID, and this is way easier to read. But the way this particular database is set up, it's car model ID, and and it's a little confusing. Let's run this query, in fact, and see how it goes. And let me go ahead and clear this. And let me go ahead and paste this and run this. Excuse me. And I may have had an error in my previous query because we do see the car model IDs lining up here the way that we should. Right. And so in fact, we could even break this down a bit more. Like we could do car ID. Let's just do car registration number. Let's just do car number of doors. Let's do even more stuff. Let's just do car.mileage just to finish it out so we get some interesting information. Let's do car model ID. And in fact, let's do car model ID. We can see the two together. The other nice thing about specifying specific columns is you get to decide the order. Let's do car model make and car model. And let's run this query. So hopefully this kind of illustrates this really well, right? This is all coming from, sorry. This is all coming from the car model table. This is all coming from the car table. The way we know to link the rows together is by matching those primary and foreign keys. And then we have all our data. Is that helpful? And what questions do people have around this and this join logic? Because this is like a super fundamental bit of SQL and Postgres.
Can you, instead of using just the ID of the table, can you use other attributes to join them? And can you demonstrate if it works?
That is a good question. Can you do that? You might be able to. I am honestly not sure. You probably don't want to. The whole idea of a foreign key like car model ID right here is, in fact, I'm pretty sure that you need to use foreign keys. Like you could connect maybe if, because the whole idea is we want to tell our database what uniquely identifies a row in a table. And that's what a join does, right? This join with car model ID says, hey, this car model ID here for this car model table, this is the primary key for this car model table. I can uniquely identify every row in my car model table with that primary key. This foreign key here for car says, hey, Postgres, this data is related to other data. These two tables are related. The way that they're related is every car has to have a car model. And the way that you figure out what the car model for this particular car is for every row in my car table is with this foreign key car model ID. And so when I want to figure out for my car that I've put up for sale on this site, and we need to do a query to find what is the make and model of Adam's car, we use these joins to connect that stuff. And just to like kind of illustrate this a bit more, let me go ahead and let me just do select star from app user. Join, what's our user profile called? Let me scroll up here and find user. Join user profile on app user dot account ID equals user profile dot, here's our foreign key, account ID. Right, and this bit here connects the user profile. And let's say where, let me do a quick search here from app user. Perfect. We're gonna find whoever JButt is, we're gonna find his stuff. And in fact, let's start out. I'll just even write that. Select star from app user where email equals jbutt@gmail.com. Right. This is James Butt, aptly named. I hope not. And this is his account information. I also want his profile. I can use a join, and the whole point of a join is to use primary and foreign keys. And that's kind of how Postgres and relational databases are designed to work. There might be a way to join on other stuff. You really wouldn't want to. You really need to be, I think, using foreign keys. And for pretty much everything we're doing here, that's what you're going to want to do, and for the assessment as well. So does JButt not have a profile? Let's get rid of this where clause. So here's a good example of query design. Let's make my query less specific to make sure my join is correct. There we go. So we're gonna go with Art Veneer instead because they have a profile. So let's run this query again to get Art's app user stuff and profile stuff. And it looks like I do have a problem in my
I think a space snuck in there in the
oh
beginning.
my god, that would do it. Talk about issues. Yeah, I had a space in the email. There we go. And James probably does have a posting. So, right, this is somewhat useful. This is a lot of information. Let me filter this down a bit and just do app user first name, app user last name, user profile city. Let's see if Art has an advertisement. Join advertisement on let's do app user account ID equals advertisement dot, I scroll down. They call this seller account ID, the account ID of the person selling the car. Right, and now, and so where I'm going with this is hopefully illustrating the power of primary and foreign keys and why, even if we could, we probably, I don't even think you can use a join that way, because that's kind of what a join is. And there is probably something that I've done wrong with this query as well. Let's see here. Yeah, and let's do add some more stuff here where we've got advertisement.date and advertisement. Let's just do advertisement.date as advertisement date. Oh, and in fact, it is named advertisement date, so I don't need to. We don't need this add at all. So we've got everyone's first name, everyone's last name, their city, the date of the advertisement. App user email probably didn't work because I have a name wrong or something. I'll figure out that part later. Sometimes it's easier to put the joins together first. And kind of where I'm going with this is join car on advertisement dot, and if we find our advertisement here, car ID equals car dot, it is probably called car ID. And we'll also add, I think, car dot registration number. And I'll probably stop here because we should take a break. The next step would be to connect this to the make and model. Though I'm awfully close, so I might just take us home. But hopefully this is illustrating kind of like how these things are designed to be used, and how primary and foreign keys work together, and what a join is. And in fact, let's just do that last join now of car model. On car model dot car ID, if I look at this, equals car model ID. And let's add in here car model make, car model. And let's run this. Join car model. Let's see, what did I do wrong here? I have a typo where join car model on car model ID. So again, the naming, people have strong feelings about which way is better or worse. Right. So now this is actually, if you imagine writing the Python code for the backend like API that's gonna send all the advertisement data to our React program, this is the SQL query that we would like construct that our Python code would run for us. Let's see if I can't get this working now with an email address. Actually, let's do app user first name equals Ellie. There we go. Ellie's selling a lot of stuff. And in fact, let's add in their email. So I can see it. Let's do that right here. And I'm just going to borrow this email and put it right here. And get rid of that space. And hopefully this works. There we go. So who knows if I had a typo or if Art didn't have any advertisements, but here's how you kind of construct a whole bunch of joins to get the specific information we need. And the joins connect all these tables together, and then it all gets filtered down with the where clause. So now I can find all the critical information for advertisements for a specific user. And I know I ran long and we need a break. So I just want to pause and see, are there any questions about this that I can maybe quickly look at before we take a good solid break?
This kind of feels like passing props. Is that a similar thing that we're doing here with joins?
I have never thought about that analogy. Short answer is I would say no. There is some similarity in how you, I think what you're touching on, actually, the term here is composition. We saw a little bit of like inheriting classes in object-oriented programming, but not a lot. But there's like a whole design strategy of composition where we have all these different tables and we can kind of use these things to compose the query that we want. And we sort of do that with props. There is some similarity of like one thing connecting to the next, but it's not directly the same. And to give a quick preview, and I think this is what we'll take a look at after the break. The reason it's not the same is what joins do is figure out the overlaps. When you use join by default, it's this one right here in the middle, what's called an inner join. A join is the overlap between two sets or lists of stuff. And that's the reason why I think props are a little misleading, because props are really kind of like passing arguments through functions. Okay, I know I ran for a bit. How does like a 15-minute break sound to folks? And then we will dig into joins. Okay, awesome. Folks, thank you very much. And I'll see you all in 15 minutes. And for some reason, I apologize, my computer seems to be a little slower than normal today, which is surprising. I'm not quite sure what's going on there. So again, think about a join as you've got two collections of stuff and you're finding the overlaps. You know, like, and the simpler examples, like the better here. You know, find just to use the cars example, find all the advertisements for Fords. Right? Like, what is the overlap between those two things? So the default join is what's called an inner join that finds this overlap, but there's different kinds of joins. You won't need to use these nearly as much, but they are important to know about. You can do a join where, like, rather than, if I go back to this example here, let's see, if I get rid of, this is a little more limited because we're getting everything for a user. Let's do like where car model dot make equals Renault. And let's get rid of a couple things here to make this a little easier to read. Like we really just need the email. I think that's enough. That'll clean it up a bit. So same join logic. I'm just changing the where clause to filter for the Renault cars. Now, let's say here, actually, I will do it up here to make it a little easier. This is what's called an inner join. And actually, let me use some simpler examples here rather than using that much more complex join. And just to kind of go through these briefly, the inner join that we've been doing, that is like if you just say join in Postgres, it does an inner join. It returns rows that have a match in both tables. A left join returns all the rows from the left table, all of them, and matching rows from the right. And that's what I'm going to demonstrate in a minute here. A right join does the opposite of that. And a full join, I believe like a full outer join, I think it actually gives us the stuff that doesn't match. Like if you look at this one right here, this last one, like it gives us not the intersections. So like we could maybe find everyone that doesn't have a Renault. If I was to modify this to be like a full outer join, but we'll kind of see these with some more straightforward examples. So again, here's just one join statement with the app user and with advertisements, right? Where we want to get everything from that app user table. And for each user, we want to get the advertisement information, and we only want 5 results. And you can kind of see this result table here. And again, the metaphor to think about is just imagine this stuff. You've got one spreadsheet of users and one spreadsheet of advertisements. And in fact, we could even build that if that would help right now. Let's see what happens if we just paste this into Google Sheets. Yeah, I love it. Go, yay, technology. And this row we can get rid of because we don't really need it. So this is not perfect. This is actually far from perfect because it's just pasted in the rows. So this may not actually work all that well. But just to really simplify things, we could imagine that these are our 2 spreadsheets and rows of data. And in fact, I'll just 1, 2, 3, alice@gmail.com, bob@gmail.com, carol@gmail.com, let's make this a bit bigger so we can see these columns. Let's do one. Let's do just 9, 10, 11. 3, 2, 1. 2023, 11, 14. Let's do 2023, 11, 13, and 2023, 11, 12. And I'm just making up some numbers here. So, and in fact, let's go ahead and go one further and let's just, make these look like tables. I've got 2 spreadsheets with stuff, right? Just let's imagine these are different spreadsheets. I've got some user accounts and I've got some advertisements. And let's, in fact, that needs to be a 3. Let's add another one here, Dave, gmail.com. I just want to see the information for everyone that has accounts and emails. So, I'm going to make a 3rd spreadsheet. And let's call this, users with ads. And we're going to want the account ID. We're going to want the email. Let's just say the seller account ID. Sorry, this should be. Yeah, the user account ID. The advertisement ID. Advertisement date and card ID. Well, I've got Alice, Bob, Carol, and Dave, right? Now, my boss has told me, hey, in this advertisement spreadsheet, the seller account ID, that's the account ID for each user. So your job, Adam, is to match these things up. Okay, well, I've got 3. That's Carol. So this is Carol right here, right? Carol's got account ID of 3, advertisement ID of 9, and that's the date, and that's the car ID. Awesome. So that's Carol's information. I see Alice in here too. She's got an ID of 1. There's that seller account ID. Alice's stuff is, it's over here. And then the car ID for Alice's ad is that. Or, yep. And then I've got Bob. Because his ID is 2. And the ID of the ad is there. And Dave doesn't have anything. So I actually don't care about Dave. So what I literally just did there is a join. Right? I just did, select star from app user, join advertisement on app user.account ID equals advertisement.seller account ID. I mean, really, I'm not grabbing, I guess I am grabbing everything, so it's star, but that's literally what a join statement is if we were to do this manually. So I don't know if that helps illustrate it a bit more as well, but I hope it kind of makes clear that there's not actually like a magic process going on here. It's literally just looking at IDs and lining them up. So was that helpful to folks? Like, yes, no, not so much. Yes, maybe. I can
Yes.
honestly use the feedback because it's hard for me to tell through Zoom.
I think that helped a lot. Can you join again?
What do you mean?
Can
Like,
you join other tables contents to this one?
oh yeah, you mean like build it out with build the spreadsheet out and with the join approach?
Yeah, actually you don't need to. It's fine. Unless
Yeah.
other people want to see that.
I think that's a pretty good idea. Would some other people like to see that as well? Can I get maybe just some nods or emojis or thumbs up? Okay, I'm seeing a couple thumbs up, and I think that's a great idea. So I'm going to go ahead and do that right now. And just bear in mind, I am sort of making up these numbers, so this data is not going to correlate with what's in the CARS database. Let me move this stuff over here and this stuff over here, and because I want to give us room. And I'll just move this stuff over here. So here's like a user account. Here's an advertisement. I think the next logical step is the car ID, right? So we've got our car table. And it has, and let me look at VS Code so I can at least make sure to get the names right here. Car ID. I'm just going to do registration ID, manufacture year, and like and like mileage or something, like just a couple things. Let's do mileage. Let's do year. Let's do car model ID. And let's do 43. Oh, let's see, 89, 34, 2. So let's do 43, 89, 2, 34, and just, I don't know, 6. And let's say, I don't know, 70,000. Excuse me. I'm just making up some numbers here. And these two cars have the same mileage. And we've got you. And let's do some model IDs. Let's make these two the same model. Let's make this one a different one, and let's make those two the same. And maybe the spreadsheets is actually what we needed to start with here, rather than like draw SQL diagrams. And let me look at this DB schema to make sure that I have this one right. Car model ID, make model. Yeah, and we have this. So this is something a bit more advanced. You can kind of, this is not a primary key, but you can use this. We'll talk about this more tomorrow, this unique constraint, so that we don't end up with 2 rows in our car model table of the same make and model. Like, we don't want 2 Ford Tauruses in the car model table. The term for that is actually sort of, I don't know if it's a composite primary key technically, but there's a whole, that's its own whole rabbit hole. Make and model. And let's just make this 4 to make it interesting. And 1, 2, 3, 4. Let's do Ford. Taurus. What are some other cars I should throw in here? Someone give me a non-Ford car, make and model.
PT
Lamborghini
Cruiser.
Diablo.
Bugatti.
Mazda,
Bugatti. What's the
Veyron.
Mazda Atenza.
what's a Bugatti model?
Veyron. Veyron, I think.
Got it.
That's what you drive, Frank.
In my dreams.
I'm a fan. I'm gonna do a Volkswagen Jetta. That's just what I have. And what's another Ford model? Explorer.
Ranger.
Focus.
Ranger. Focus. Okay, Focus, because I like the word focus. Beautiful. And you know, in hindsight, I feel like we really should have just started the day with this. Now that I think about it, so we've got our car table, and we've got our car model table. Let me go ahead and make these bold, and I'll share. I'll just share this sheet. I think. Let me go ahead. In fact, name this cars database and joins examples. Okay. And someone just remind me, and I'll move this into our class folder and maybe throw a link to it in the notes for today. So we've got the car model. If I look at this advertisements, I can see that for these advertisements, you know, this first advertisement has car ID 89. So that's where's my annotate tool? Perfect. Yeah, in hindsight, this is definitely the way to go. I'm sure there's a better way to do like arrows in Zoom, but this is a good start. Right, and then these two link up. And then to use another color, green, these two link up. Right, and so I literally, with these little arrows, I just did a join. Right, it's the same thing that we did here of linking these things up. And so to kind of go back to the request of let's write a more expanded query. And once you start to get used to this is why sort of seeing that vertical like SQL syntax is really nice. So let me see if I can kind of write this out that way. So let's do like select star from app user. Oh man, how do I don't know how to get it to have multiple lines in the same cell. I apologize. Join advertisement on app user dot account ID equals advertise dot seller account ID. Join car on, and by the way, the order of like what goes first or second on the equal side for this on statement in a join, I don't believe it matters. Because you know, it's as long as we're giving like the table names here. So I just sort of, for consistency, I'll start with whatever the first thing is. So like advertisement is joining car here. So that's why I'm going to do advertisement dot car ID equals car dot car ID. I don't know if is this easier for people to read, or do people actually prefer it all on one line? For me, this is a little easier.
Vertical.
Sorry?
I think multiple lines is easier.
Okay, awesome. Right. And so let me actually rename this table too, so that this is let me rename all of these because this is user, this is really app user. This is advertisement. And then this is app user join. Advertisement, and this is car. And this is our model. And this is why kind of once it starts to click, I actually think joins are a lot of fun. And now we're gonna do app user join with advertisement joined with car. And I'm gonna copy all this stuff. And we're gonna also grab from the car. I'll just grab all this stuff. Right, so we get
Hey,
this.
Adam,
Yes, what's up?
just real quick, I just thought it might be helpful to visualize, since the join is added in these columns. Could you color code the columns on?
Oh, yeah, that's a great idea. I love that. Let me do that right now. You mean like kind of like make all of these like a light blue, for example?
Yeah, exactly. And
Yeah,
give them all color, and then in your join table you have below, use the same colors for the respective columns.
yeah, I think that's an awesome idea. Thank you so much. I'm a huge fan of colors. And these, the advertisement. Let's make that, we're gonna run out of colors, but we'll make the advertisement purple. And we'll make all this stuff like that color. Is this color scheme working for folks?
It's very vibrant, but it gets the message across.
Yes, it's my palette is a little limited, and I'd rather go for vibrant and subtle. But yeah, is this useful to help visualize this? Yeah, that is a great idea. I'm definitely stealing that. And undoubtedly, like better color palettes can be chosen, but just to, and also I know I've got two more tables here, and I'm trying to get to like the really vibrant yellow and green last. So yeah, we had this join here to join these two tables together. And that's exactly what happens, right? And now my boss is like, all right, Adam, cool. But actually, I need to know like the information about like what cars go with these advertisements and like what's their mileage and stuff, right? So my query now has to just do another join. And I've got this data that I already have. So let me go ahead and color code this as well. That is little, is that the blue? That is awfully strong blue. There we go. And then these are that. And then this stuff is here. Yeah, this is a great idea. And do just bear in mind that remember I am simplifying the actual cars database a bit so that we don't have to spend as much time putting everything else out. So if there are some minor discrepancies between this and the actual data schema, that is why. And let me clear those annotations. Yeah, I love this. So now my boss is like, all right, Adam, cool, but let's join. And let me just make this that sort of gray color. Now I need information about the car. What's the mileage and the year? So I've got another spreadsheet or CSV file. You'd be shocked how often CSV files are used. I'm like, all right, I got to match up. And my boss is like, Adam, the car ID here, match that up to the car ID in the ads and give me a report on that. Put that in the spreadsheet for me. so that I can see like what, ads we have this month and how the company is doing. Cool. Well, we've got these 3 ads by Alice, Bob, and Carol. So let's find the cars for those ads. So there's a bunch of cars in here. Now in a real world, I don't know if these cars would have gotten in there without an ad, but maybe users have taken down their ads. Maybe someone tried to sell their car and it didn't work, so they turned off the ad, but you can still like have your car in the website because that's nice for the user, right? Or maybe users haven't created ads for these cars yet, but they're going to soon. So there are a bunch of possible reasons why we could have cars here that don't have ads. But so these 3 ads do have cars. So I need to find car ID 2. So that one's right here. And let's put that right there. And I need to find car ID 34 for Bob. And let's put that right here. And I need to find car ID 89 for Carol. And remember, our other user, Dave, hasn't made an ad at all. Actually, no, that works. This makes sense. If I was designing this, I might include like the user ID in here, to be honest, because cars kind of belong to users, but that's a question for another day. Let me just make sure that I didn't forget that, in fact, from the car database. No, yeah, it's not on there. So that I would actually argue that's a flaw in the schema design, but that's out of scope for what we're worrying about right now. Because you kind of want to be able to know what cars are for what users. All right, let's add some colors here. And I apologize. My Chrome seems to be fighting me right now. Let me close out some tabs and see if that helps. Chrome is kind of like a notorious memory hog. Okay, there we go. Sorry about that. I think we are going to have to cross into green territory for the cars. That one is, I think, a little too close to our other gray colors. Maybe. Yeah, there we go. So ugly, but visually distinct. And I apologize. I'm not sure right now why my Chrome is freaking out, to be honest. Let's see if I can't maybe like close out more tabs and solve this issue, because it is a little frustrating. This is driving me a little nuts, but I think I'm just going to keep rolling because I'm not sure what's up with my laptop at the moment. I'm afraid that if I like page refresh, it won't work. So maybe we'll just take a very short technical break after this. But you can all kind of see where this is going. And it looks like Google finally finished freaking out. All right, it's telling me that not sure what exactly happened here. I apologize, but we've got a simple solution. I'm going to copy all that stuff. We're going to reload. Let's see if anything is missing. Okay, perfect. Nothing lost. I apologize about that, folks. Here we go. So, and this is a good pausing point, probably, because you guys, I think, sort of can see the pattern here now that like you can see how we would add car model as well. And
Hey, Adam,
yes, what's up?
would you mind just zooming out a little bit, just so that
Yeah,
could see more of the big picture?
yeah, that's a great idea. Thank you, Andrew.
Thank you.
That is a great call. And look at all these beautiful colors. Yeah, I love this. So you can sort of see, and in fact, as long as I'm doing this. So while I'm fiddling with the colors, what questions do people have? And is this helping to sort of illustrate what a join is and how they work with foreign keys and primary keys? Awesome. Yeah. Next time, what we'll do is, I'll ask someone to do this with a spreadsheet. That actually, I think, would be a lot of fun. And in fact, if you find it helpful to use a spreadsheet for designing your data schema or constructing your joins, I would say go for it. It might feel like it slows you down. It took me a little while to do this, but this was, 20 some odd minutes of making up some data. And you all know from experience, you can easily spend over an hour with a tricky programming problem. So if like a visual aid like this actually helps you construct your joins and you make up a little data along the way, I think you'll actually end up saving time and effort. And to kind of tie this back to the different kinds of joins, remember we've got this user over here, Dave, that doesn't have any ads. And we have some cars that don't have an ad either. And if I go back to this lesson on joins, that default join, an inner join that overlaps, that's exactly what's happening here, right? We exclude the stuff that doesn't overlap. And the way that Postgres knows what connects and overlaps is with those primary and foreign keys. So I'll run the SQL query in a bit, but like if I did a left join here, we would also get Dave. And that's actually maybe a really good illustration of a left join. To go back to this diagram here, we would get all the stuff on the left side of that join statement, the table on the left, even if it's not in the one on the right. And sometimes we want that. Usually we don't. But sometimes we do. And similarly, if we did a right join here with the car stuff, we would get all the other cars. Now, I made my life a little harder because and these would just be rows with empty data. Like the columns for these result rows would just be empty. So this is what a right join would look like. And hopefully that kind of illustrates about the different kinds of joins here. And again, on a practical level, we usually, almost always for this class and everything you'll do here, want to do an inner join. And that's just, if you just say join, that's what Postgres does by default. But those other things are useful to know. And every now and then there's a situation where you want that data. So let me just pause and check in and see how people are doing. And if folks have questions, and if we want to, if someone wants to do the last join, I can sort of be the driver. I mean, I could also share the spreadsheet of we could add the car model on here as well. We can do that. Or if people are feeling good, we can maybe move on and look at some other stuff. Okay, cool. I'm gonna roll on to some other things because there are a couple things that we want to cover. I know it's been a long day. I appreciate it. The CSV stuff, I will make some time, I think, after lunch to dig into that more. The good news is that like the most important 75% of that takes about 5 minutes.
Hey, just a quick question.
Yes.
If you could go back to the spreadsheet real quick. So the seller account ID and then the user account ID. Would it be helpful? I mean, for me, it'd be helpful if if the IDs were named the same thing.
I would agree.
Yeah.
That was a design choice by our other instructor. And to be fair, there's a case to be made for that where the name has meaning so that you know,
Yeah.
like, hey, this is the account of the person who's selling this ad, because there might be
Right.
multiple people that can be involved.
Right.
But in general, I agree with you, and I think that's a good like a simple foreign key convention is the foreign key table name underscore ID, like app user account ID. Because if I see this and I see a column that starts with the name of another one of my tables, that kind of tells me this is probably a foreign key. And that's how I would recommend naming your foreign keys, actually, is just like the name of the table that the foreign key references underscore the name of the foreign key column. So to actually, let me jump to the code very quickly just to demonstrate that. So as to your point, Andrew, with the advertisement, I would kind of concur. I would name this app user account ID. Because and this is a little different with everyone, but the more you do this, like if you see a column name that starts like with the name of another table, like that is a pretty good signal that this is a foreign key. Yeah, so I think that's a really good point, and I would sort of concur. There's arguments to be made on both sides, and some of these things are sort of like eternal arguments, but yeah, in general, I would agree. That's also why I find it easier, like just to name stuff ID. Like I would just make this ID, right? Because then this becomes even easier. It's just app user ID. But that's you know, both are reasonable design choices. What other questions or thoughts do people have about this spreadsheet and this stuff before we move on? And actually, as long as we're doing this, I am just gonna wrap up our very last join because we're looking at it and talk about it, so we might as well. So we would join car model on car model ID equals car model ID. And the awesome thing is that now that we've started color coding, it's so much easier just to add it. Joined with car model. And let's make the car model been saving red and orange. And we'll make that like a nice light orange. And we'll put that right there. We'll put those right there. Oh. And you know, now my boss is like, Adam, cool, but actually in my report, I want to know the make and model of the cars. Here's another spreadsheet. If you look at the car model ID here, it'll match up with the car model ID in that other spreadsheet that has like the actual cars for sale. So please get me that information. And then my boss sees that someone is selling a Bugatti, and my boss gets really excited because we're going to make a ton of money, and that's really kind of a fun thing for us to brag about. And voila, we now have 3 joins color coded, which is awesome. I'm a huge fan of this. And let me go ahead and get rid of all these columns that we don't need, or these rows. And let's get rid of these as well, as long as we're doing this. And then we'll talk about group by and join, and a little bit about CSV stuff. And I'll clean this a bit more up for everyone, but now we've got pretty much everything in one awesome view. Yeah, and thank you so much for suggesting the color coding. We'll definitely kind of use this more. I've done this so much that when I look at, like, you know, that those draw SQL diagrams, it's something that I'm very comfortable with, but that's, you know, sometimes you get so used to something that you lose that perspective. So this is awesome, to be honest. Okay, cool. So it's worth taking the time to read through the rest of this join lesson. I would actually just recommend like running these queries. These are all significantly less complex than what we've been looking at, actually. It is useful to see, because it's nice to see too where like how where and this get combined. And the reason to type this out too is to start learning, you know, some of the common gotchas of like typing out SQL, and the kinds of errors that might pop up. The one thing I want to point out in this specific example right here is note this kind of interesting and clause to our where statement with this Postgres function named extract. And we're extracting month from the advertisement date, and we're saying the month is 5, right? The 5th month of the year. Postgres has a lot of functions that you can use inside your queries like this. And you'll see a little bit of this, but there's just too much to see. Some of the SQL assignments, like we saw average, there are some others as well. There's some great date time functions. We can't go into them all, but I just want to point this out because Postgres is extremely powerful and robust. And so to kind of jump back a bit, the one thing I did want to talk about that is not about joins is group by. And just to recap, we have this count function. And again, uppercase or lowercase, it doesn't matter. Just sort of, if it's an SQL thing, convention is uppercase or readability. But when I'm actually like writing code and constructing queries, I just do stuff lowercase. For teaching, I'm doing stuff uppercase. So note a couple interesting things going on here. We're counting the distinct models of cars, right? So in fact, if I got rid of this distinct and I just did count model, we'd get, I think, a whole bunch. Well, I think if we did make, we would get a whole bunch more. And if I do distinct make, there should be less. There we go. Right, because there's like a Ford Taurus and a Ford Explorer. So there's multiple rows in car model with the same make. Go back to this illustration of our car models. two rows with the same make, if I just do plain old count, it's gonna count these two things because it doesn't know that we care about different things. If I do distinct, it isn't going to count forward twice. It'll say, hey, we already saw forward. I've got 3, or in the actual database, 26. So, these functions are really powerful, but sometimes we need to do more. And there's this really cool clause that we can add to our select queries called group by. And this lets us group up our results, which is exactly what it sounds like. And I'm just going to jump down to this result and then I'll run this code because I think that seeing this helps illustrate what group by does, right? We're grouping by the make of the car and we're counting the results. So these things sort of combine. And we haven't seen this, but you can also add ascending or descending. So just to kind of break this into bits. I've got a count of all the different makes of the car. There's no real order to this. And usually when we're doing this kind of stuff, it's helpful to have some sort of ordering. So here we say order by the biggest number, the order by the makes of car that have the most models. And you can see here in this result set that the cars database has the most BMWs. Right. And if I wanted to go a step further, I could even do like limit 5 to get the top 5. And I want to pause and check in here and see what questions people have, or if there's bits of this that you'd like me to go over again, because the group by is, I think, a little funny to wrap your head around and stuff kind of interacts, but it's super useful. And is this working with this split screen approach? Okay, can people read this and see code? Okay, awesome.
Sorry to interrupt.
Yeah.
So can you do like one query, like real quick?
Yeah.
Can you query all the users that is driving the BMWs?
Yes, you mean that have ads to sell BMWs?
Oh, I mean, yeah.
Yeah.
I mean, that correlates with the BMW.
Yeah. Yeah, exactly. All the users that have BMWs. Let's do app user.email and car model.make from app user. And there's going to be a little bit of a journey here, but join advertisement on app user dot, I think it's accounts ID, and let me consult my SQL. Yep, account ID equals advertisement dot, let me make sure I get this one right. So I do agree with you, Andrew, it's a little counterintuitive. Seller account ID. And actually, I'm gonna do limit 20 just for the moment. Actually, I'm not even gonna worry about the limit. I'm gonna just go ahead and run this query just to catch any typos. And indeed, there is something that I'm missing here. Let's see, select. Oh, because yeah, I see the problem. Okay. Let me go ahead and construct this in the queries table now that I've got this going. Because I thought it'd be easier to do it in there, but I think this will be easier. Right, so we connect the app user to the advertisement, and we need to do that because the advertisement connects to the car. And let me make sure I have those fields right. Car ID is the foreign key on advertisement that connects to the primary key car ID on our car table. Join car model on car model ID equals car model ID. So let me see if this works. And then if this works, I'll add the where clause. And to be honest, the way to build a query like this, so I've done this a lot, so I can do it relatively quickly, but type it out in the SQL, and each time you add a join, run the whole thing. And the problem I ran into is that I was asking for car model before I'd added car model as a join. So it looks like I do have a syntax error here. Maybe I just didn't paste everything correctly. Let's clear the buffer and try again. I will come back to this if that's okay with you.
Yes, definitely.
Okay, yeah, because at this point I just have a syntax error.
I think it's line 61. Car.id should probably be car underscore ID.
Oh, right here. You are so right. Thank you, Megan. Let's see if that does it. Car model, car ID. There's some other syntax error here. Yeah, I might come back to this. To add the last bit, we said where car model dot make equals BMW. Is that correct?
Adam,
Yes.
didn't you change one of the column titles without updating the table?
Oh, you mean like in this code?
Yeah, in your schema, I think.
Ah,
I think Andrew brought up the name of one of them and he changed it. Could that be causing the issue?
I did. However, that doesn't, so that actually raises an excellent point. I can change whatever I want in this SQL file and I can save it. But until I actually execute the code in here against my database, the database doesn't change. Like if we look at the car table, these names are all still the same. And if we look at the, I think it was like advertisement table, these things are we've still got seller account ID there. I did make some changes here and stuff, but I would need to run, remember, I would need to like execute that SQL to actually change the database. The thing to remember is that the Postgres database, once we create it, it's not talking to this SQL file. And this is a little different than, you know, with a Python program, whenever the program is running, it's looking at the source code and executing it. But here we run this SQL and Postgres builds these tables and done this stuff. And then that's what we interact with when we interact with Postgres. So that actually raises a really good point. And does that sort of make sense, what I was just saying there?
Yeah, it makes sense.
Awesome. Yeah, no, that's a really good question. I have some sort of syntax error going on here that, and it could have in fact been that, but I will figure it out later. But in essence, this is what the query is. There is just a typo or something lurking.
Don't you need to add the group by syntax in here?
No, not for this.
Okay.
So we could, if we wanted to count all the well, so you raise an interesting point. So I think I got this query working now. Yeah, okay, so I did get this query working now. So the where clause filters out everything that's not a BMW. And if I wanted to count, I could just do this because I know already that this query just gets the BMWs. We can get the same information from group by. Group by works a little differently because with group by, we can do a query to get the count of all the different models. And you can actually see that example right here, though we then run into a syntax error because group by is a little special and you can't actually use like a where clause. Instead, we have to use the special keyword having. So I can do this. And then if I wanted to add BMW, I can do that as well. And in fact, if I wanted to just see it for all the models, I don't need this having clause to filter at all. So this query might be like, if we want to get information about one specific model, group by is useful when we want to get like information about a bunch of our categories, right? Because I could execute this query 5 different times for BMW and Ford and so on. Or I can use group by to get it for a bunch of them in one go. Does that help a bit?
Yes.
Awesome. Yeah, great question. Actually, that's a great illustration to make. So that really covers everything I wanted to look at with group by. We're coming up towards the end of the lecture. So, there was stuff that I wanted to talk about with CSV. And maybe what we'll do is just take 15 minutes after lunch to dig into it a little bit more. But I can show you all like the most important piece extremely quickly, which will actually be quite useful. And this is from today's lesson, and this is also working with the CARS database. And the short version is, and there is a copy command that we can use, and we can give it a table, and we can give it a file path. And we can tell Postgres, export a CSV file, and have headers. And the good news is this can become a lot simpler because CSV by default will use a comma to separate things, right? If I wanted a different delimiter, I could specify that, but I don't have to. And Postgres has this really great / copy command that's a little bit of a shorthand, and it lets us use a relative path. So I'm sort of, as I said, I'm sort of jumping to the good parts here. And let me make this a bit bigger so that I'll just make the font size a bit smaller. And let me just copy and paste this. And so now if I run this, this tells me this happened correctly. Copy 785. Let's actually quit the database and look and confirm, hey, this advertisement CSV file, that indeed was created. There's, oh, my Explorer is open to the wrong window. Let's go ahead and just take a look at this file to confirm that this looks like what it should. And this is our advertisements table from Postgres, which is awesome. And we have all this stuff here. You know, we can see the seller, you know, the seller account ID, the advertisement date, we have the CSV headers. And so just to recap, let me log into Postgres and connect to our cars database. And let's just export another table or two just for fun to watch this happen. So I'm going to use that as my reference. Let's copy something a bit more interesting. Let's copy car model 2. We'll just name it car model.csv. I just have to use this command CSV. Header is, so these are the headers of a CSV file, the name of each column, essentially, your field. And if I don't want those, I don't include header, but if I do, I include header, and you almost always want that. And in fact, let me go ahead and just, so I don't have to keep closing Postgres. And here's the car model CSV file. Now I'm in the same directory I ran Postgres from. And when you use this copy command, and let's take a look at cars CSV just to, for car model. And we've got all our car models. And you could do an absolute path here instead of a relative path if you wanted to as well, you know. But I would recommend relative paths are just much shorter to type. The other thing that is very cool is we can export a query into a CSV file. So here is this query that I've constructed, and it has a join, and it's actually similar to the query we were just working on. It gets me all the advertisements that are Fords, and it just gets me the advertisement date and the model of the car. And something we haven't talked about a lot is you can nest queries. I've got this query inside these parentheses. And what Postgres does is a table is just a bunch of rows, right? And when you run a select query, it gives you a bunch of rows. So you can kind of treat that like as a table or as a data source. You can do selects on selects. There's all sorts of crazy stuff that you can do. And I need to update this a bit, and I will, to use the shorter version of copy. I apologize about that. But let's go ahead and export my query to a CSV file. And let me go ahead actually and just use that as my model, because I do need to do a little typing out carefully here. So I've got this whole query in quotes, in parentheses. You can even save queries as Postgres functions, by the way, or they're called stored procedures or views, but that gets a little more complex. So I didn't want to get into that. You can do a lot of amazing stuff. And it looks like I have a syntax error at or near join, which I'm a little surprised by, because I think that should work. Let's see what I have going on here.
Does it have to do with that slash command not requiring a semicolon and maybe finishing at the end of the first line?
That is a possibility. Yeah, it looks like it is a paste issue with the parser at end of line. So, yeah, I may just use this much bigger copy command and let's see if that works. And I'll clean this up a bit and get rid of some things we don't need. The big disadvantage here is with this copy command that's not the / psql command, you have to give an absolute path. I could do it with / copy. I would just have to type it out as well. Let's do something much simpler. Select model from car model. And let's move that to, let me actually use this as a reference. And I apologize that I got a little lost in the weeds here. To all models .csv, CSV header. And I'll update the lesson to have this better example. So there we go. So there's, I think it was a copy paste issue. That is an excellent point. So this is a much simpler query, but it does accomplish the same thing of showing that we can use an SQL query and spit that out into a CSV file. And you can do it with the join and stuff. You just would have to type it out manually. And so here we have a list of all our models. And then the last thing I want to show is CSV, and then this will be a good point to wrap, is importing data. You can do this with JSON as well. And there is a bit of a guide here. It is honestly a bit more tricky and less useful because you're usually using CSV when you're getting stuff into and out of Postgres this way. Normally, if we want JSON, I'm probably going to have a Python program that runs an SQL query and gets the data, and then the Python turns it into JSON. So I need to rebuild my cars database because I already did a bit of this. I already did a bit of sort of cleanup with what I was doing. So I'm just moving to a different directory where I have that cars database repo clone. So I can just very easily do this. Drop database cars. There we go. Now let's try running it and building the cars database. There we go. Voila. So I kind of went through all of this because we have a bunch of models in here. What we don't have are Hyundais. And I did make a little CSV file, which I probably need to fix the link to. I apologize. It's hiding right over here. And I already had this in my database earlier from when I was preparing the lesson, and that's why I had to drop it and rebuild it. But I just wanted to demonstrate importing a CSV file to add more data to a table. So we can use the same copy command to import. So this CSV file, let me go ahead and let's very quickly look at the raw CSV. And after this, we'll wrap and maybe if we'll do, I think maybe another like demo session in the afternoon to talk about some more schema design stuff. So the CSV file is really straightforward. The most important thing here are the headers. You do want these to match the names of your Postgres columns for the table that we're going to import this into. There are ways around that. You can see in this copy command that I'm about to run, there is a way to specify what goes where. But it's going to be way easier to just have the CSV file headers match your column names. You can always just modify the CSV file. And I haven't played with this too much, but I would just keep this in the same order as what you have in the CSV file just for consistency. And now we can run this and we can import our CSV data. And I am going to jump back over to VS Code. And again, the reason I'm jumping around has nothing to do with like what you have to do, but I just find it actually what I want to do is I can just do it this way with an absolute path. I find it way easier to just use the relative paths for imports, to be honest. And so that's why I'm jumping around a lot, because I want to keep my life simple. And it's easier for me to just move around to the directory that I want to like be in to import or export CSV to work with files from inside pSQL, then inside pSQL try and type out some path and not get like autocomplete. So now I just moved myself to where this CSV file is. I could have copied the file to my directory as well. And now I do want to log into pSQL and connect to the cards database. And now let's do copy car model, make model from, and now I can just and I have a typo in the file name, and that would be the problem there. Now I can just give a nice relative path and my life is simple. And note we have this copy 8 command. And now if I do select star from car model, all the way at the end here are these Hyundais that have been added. And the cool and important thing to note here is I did not have to pass in a car model ID value when I imported this data. Postgres knows, because we've told it when we defined this table with like serial primary key, Postgres knows and will create that primary key value for us. And you can kind of see this hint here, like there's actually a default value for this car model ID column. And it's all this kind of more complex stuff that we don't have to worry about. And it basically boils down to auto incrementing integers that Postgres does. But so there is this sort of like fancy default value. And so that's why we don't have to put it in there. So that's the last piece that I wanted to show you all, because that is going to be useful as well. I realized we ran a little bit long. So I think this is a good time to stop. The pieces we didn't get to from this lesson on CSVs are a lot less important. The JSON stuff is not that critical, to be honest, and you're not going to see it much in assignments or on the assessments. I have some tips here on how to take a CSV file and look at it and turn it into a schema. And this is something that you will want to practice and that will show up on the assessment. And we do have an assignment today for that. And I think this is a good one, maybe to go over as a group, and based on feedback from yesterday, I think that I might do some revisions. And I would recommend doing this last today because the other assignments are going to be very good practice for SQL queries with joins and group by. And that's the more important thing and the thing you'd want to really learn first anyway. But this project is another scenario for 64 slices of pizza. And this person wants you to build a database too. And you have some CSV files. There are different stages here and some recommendations. There's some queries that would be nice to have. But as I said, I think this will be a good one. Let me give this a once over, and maybe we'll quickly gather in the afternoon to take a look at it before diving in. But just to show you all, there's some CSV data here. Some of it is deliberately a little messy, because you will want to make some design choices, but you've got essentially products, the pizzas for sale. We've got some toppings. We've got some store locations. We've got some drivers and pizza deliveries. This is more driver information. And then we have some order information. And it looks like there's maybe a typo here to fix. So this one's a little more complex. And I think looking at this one together later in the day makes sense. And also this one is, we're going to be coming back to this one tomorrow as well. So definitely start off with these first two assignments right here. And these will practice all the SQL query stuff. That should really be your priority for today. And then once you knock those out, move on to, you could, if you want more schema design practice, you've got that here with this restaurant schema design tutorial. You've got a more open-ended Grubhub design. And then this 64 slices is a bit more of working with CSV files. And I think maybe I'll just get us together a little bit in the afternoon to look at that and maybe get started on that as a group. So that is sort of the plan for this afternoon. And let me go ahead and, well, actually, before I stop the recording, do folks, I know I just went through a lot there, so I just wanted to check in and see if folks have any questions, whether it's about maybe the copy command or anything else that it's worth looking at before we wrap up for lunch.
I don't know if it was just me, but you cut out really bad right there.
Oh, I'm sorry about that. That may have been me. How is my internet now?
It seems good.
Awesome. Okay, cool. Let me go ahead and stop